Okay, here we go. Yesterday we began talking about different kinds of word problems. And today we're going to use a strategy, a different strategy that you've probably not heard about before. That's called bar models when we are trying to solve a word problem. We're trying to solve a word problem. It's called using bar models. So here we go. I'm going to go over to the next page. I'm going to be modeling this one. You don't need to worry about your iPad. I'm going to model this one, and then you'll be able to practice on the next ones. So here we go. Here's our word problem. It says Jessica picked 8 apples from a tree. Frankie picked 9 more apples than Jessica. How many apples did Frankie pick? So I know my story starts out, and I know that if I'm thinking a little story, I see in my head, I see Jessica, and I see her, she's climbed up a tree, and she's picked, what?
8 apples.
8 apples. So I have the start of my word problem. I know where I'm going to start, right? And I'm going to start with 8. Then it says here comes Frankie. He comes along, he climbs up the tree, and what does he do? He picks 9 more. So if he picks 9 more, I know I am adding, and I know I'm going to add 9. And then the question asks us, how many did Frankie pick? How many did he pick? So I know that I'm looking for my result unknown. She picked 8, he picked 9 more than her. My result is unknown with addition. I'm going to teach you how to do that using bar models. Using a bar model. Here's what I mean by a bar model. I know that I started with Jessica picking 8. So I'm going to draw a bar that represents the number 8. There's Jessica's 8 apples. Now, I know that Frankie picked 9 more than Jessica, so he picked 9 more than her. So then I'm going to draw another bar to represent the 9 more that he picked than her. The 9 more that he picked than her. And this time I'm going to draw another bar. I'm going to connect it right to her bar. But this time my bar is going to be a little longer than her bar because his has how many in it?
8. 9.
His has 9, hers has 8. So it's kind of going to look like this. In my mind, I'm picturing that there's her 8. 1, 2, 3, 4, 5, 6, 7, 8, right? And in his, I'm picturing about that that he has 9. One, two, 3, 4, 5, 6, 7, 8, 9. So his bar is a little longer than her bar. And if I put the 9 and the 8 together, then I'm going to find out my result unknown. I'm going to find out how many he did pick if he picked 9 more than her. So if I do that, if I put this 9 and this 8 together, if I were to go along and section these off, I knew there were 8 here and 9 here. I'm going to find out, watch, that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Or I already know this as one of my facts. Do you see one of the other reasons why it's important to know your facts? Because you should already know that 9 plus 8 equals 17. So that is another reason to know your facts to automaticity. But then this bar would show me the number 17. Now, when we do bar models, we don't draw these little dotted lines. I only did it to show you what you should be picturing, what it's telling us. So that's what it's telling us. If I take these 8, put them with these 9, then these 2 bars are the same as what? 17. 8 and 9 are the same as having 17. That's what this means right here. This equal sign means they're the same on each side. How much is 8 and 9?
17.
17. And we said 8 plus 9 equals 17. So 17 is equal to 17. Got it? 17 is equal to 17. That's called a bar model. That's what bar models are all about. Now, does this bar model remind you of anything you've ever seen before? I'm hearing it. Good. Say it loud. And so you've learned about a part whole before. So this looks very similar, other than our bars on a part whole. Exactly, on a part whole, our two parts, the both sides are the same. So if I were to have 2 plus 9, my first bar would be about this short. My second one would be pretty long, right? We're going to show the difference in the numbers using our bars. And then ours would be like that. So a part whole, each side is equal, where in bars, we're actually going to try to make our bars to represent how large or how small our numbers are. But it is very similar to a part whole. So, but it's just called a bar model. It's just a different strategy. Thank you for listening, so you did a really nice job, and I like how you're already thinking about things that it's already about. Remember this problem? We had an add-in plus an add-in equals a sum. Both numbers in an addition problem are called add-ins. This number is an
Add-in.
This number is an
Add-in.
Both numbers in an addition problem are called an add-in. The answer when you add is called the
Sum.
The what?
Sum.
Absolutely, it's called the sum. Add-in plus add-in equals sum. We are mathematicians. We're going to use that math language. Nice job. We're going to continue. I'm going to go ahead and cut the recording off, but we're going to continue practicing with some more that you have on yours. Thank you for doing a nice job.